idea how many times I re-recorded this lecture. The next, I'd like to do 2 more problems. And in 37 through 40, find the series radius of convergence. So pretty much the middle part is almost identical. We want to get to this last part, and I want to do 2 examples out of those. First problem would be number 38. We came across this a bit before, not as much as we like. In the coming sections, we're going to have to find something like that, and those are called binomial series. So, find the radius. They just want the radius of convergence, which means I just need to take a limit. This is definitely not geometric because of the factorial part, so I'm going to apply the ratio test. I'm going to take the limit as n approaches infinity of a sub n plus 1. And if you recall, this is a bit tricky. A sub n plus 1 in a factorial, you list literally what you see, plus one more term. If I replace this n by n plus 1, wouldn't that be 2 into n plus 1? And I'm going to write this in 2 steps for your notes because I know there weren't enough practice problems. The denominator will be 2 times 5 times 8 times 3n minus 1. Literally what you see, that's how factorials always work. Plus, or times the next term. If I replace this by n plus 1, and I'm going to write this again in 2 steps, times x to the n plus 1. And I'm going to divide that by, so multiply by the reciprocal. The reciprocal of this would be, and all of that's being squared. Reciprocal would be 2 times 4 times 6 times 2n, 2 times 5 times 8, 3n minus 1, x to the n. Now, you will figure this out quickly. Any form of factorial, the hard part is just writing it out and figuring out what it equals, because things cancel out nicely. Now, this part right here, wouldn't that be 2n plus 2? And this part right here, wouldn't that be 3n plus 3 minus 1 is plus 2? So I'm really looking at 2 times 4 times 6 times 2n squared times 2n plus 2 squared over 2 times 5 times 8 times 3n minus 1 also squared, and the green would be 3n plus 2 squared, x to the n times x to the 1. And here, oops, I forgot the square right there. There you go. And now this is simply 2 times 5 times 8 times 3n minus 1 squared over 2 times 4 times 6 times 2n also squared. And another mistake I caught, when you divide x to the n is in the denominator, those cancel out, and this will cancel out with this, and this will cancel out with this. So pretty much out of all of that mess, I'm left with the limit as n approaches infinity of what? 2n plus 2 squared over 3n plus 2 squared times x to the 1. And if I apply this, I will notice that that's going to be the limit as n approaches infinity. And let's see, if I combine those and divide by the highest power term of the denominator, that would be 2 plus 2 over n over 3 plus 2 over n. And we know from the previous sections that would be 0, so I'm looking at absolute value of 2 squared, which is 4 over 9x. And this is the limit using the ratio test. If I set that to be less than 1, and again the author always wants an x, absolute value of x would be, if you multiply by 9/4, that would be my radius of convergence, and that's what they want. Again, we're going to have a discussion on this in our next class meeting. If you have any questions on that or the homework I'm going to give you, we will pick this up in our next discussion class. And the last problem I wanted to discuss in this section, I'm sorry I keep on moving the grids up and down. Again, this is my first video. Actually, it's the first video that I'm going to publish. I messed up a lot of them before, so I said no matter what happens on this, I'm going to actually tackle it and submit it, even with all the flaws in it. Alright, so here we are, last problem. This is something that I talked about that comes up a bit more than you like, and we discussed it in class in details. Hopefully you remember. If not, here it is one more time. And I noticed this is raised to the n power. So probably the best bet is to take the limit as n approaches infinity of what? The nth root of the absolute value of n over n plus 1 to the n raised to the n times x, oops, I'm sorry, like I said, I'm going to make some mistakes, all raised to the n power. I know that confuses few of you. If you distribute the power n, you should get literally what this is, and we know that this n will cancel that n, so pretty much I'm left with the limit as n approaches infinity of n over n plus 1 to the n times x in absolute value. That would be the limit as n approaches infinity. And here we're looking at what? 1 to the infinity, and this is the problem that we did too many times. Either you have to derive it using L'Hopital, which is really long, or this specific problem came up for us. This is the third time you're seeing it. I would recognize that I might have to switch this, and the price for switching a fraction, the power alters from positive to negative, limit as n approaches infinity, and isn't that 1 plus 1 over n to the n, always to the negative 1 times x? And that would be the limit as n approaches infinity, and we know what this is. Again, I derived that for you on the board, 3 times, and that would be pretty much what? No need for absolute value because that's always that is. And what would that be? So this limit is this e to the negative 1, so I'm left with e to the negative 1 times absolute value of x, and wouldn't that be absolute value of x over e? And what I want, since I'm using the root test, the ratio test, I said that e to be less than 1, absolute value of x is less than e, which is my r, and once I find that, that would be my radius, and that's pretty much what they want. So again, first video, I apologize if I messed up a few times. The homework, this is section 10.7 on page 633. I would like you to do numbers 1, 3, 5, 11, 15, 25, 27, 37, and 39. And tomorrow in our class, we will discuss this. And that would be it for that section.